Nearly half a century ago, a small spacecraft left Earth carrying one of humanity's greatest ambitions, to explore the giant planets and then disappear into history. No one expected it to become the most distant human-made object ever created. Launched on September 5, 1977, Voyager 1 was never designed for eternity. Engineers built it to survive a demanding planetary mission lasting only a few years. Its computers possessed only a tiny fraction of the processing power found in today's smartphones, and every instruction had to be planned long before the spacecraft reached its destination. Yet sometimes history is written by machines that outlive every expectation. Voyager 1 first transformed astronomy during its encounters with Jupiter and Saturn. As it approached Jupiter in 1979, the giant planet emerged not as a peaceful world of colorful clouds, but as an enormous system overflowing with energy. Its atmosphere contained storms larger than Earth, while powerful lightning flashed through layers of turbulent clouds. The famous Great Red Spot appeared even more immense than scientists had imagined, a gigantic storm that had already been raging for centuries. Perhaps the greatest surprise came from Jupiter's moon Io. Before Voyager arrived, many researchers believed moons were cold, inactive worlds. Instead, the spacecraft photographed towering volcanic eruptions blasting hundreds of kilometers above Io's surface. It was the first confirmed evidence of active volcanoes beyond Earth. That discovery completely changed planetary science. It proved that distant worlds could remain geologically active long after scientists expected them to cool and become lifeless. Voyager also measured Jupiter's enormous magnetic field, revealing an invisible environment filled with intense radiation capable of damaging unprotected spacecraft. Suddenly, Jupiter became far more than a giant planet. It became an entire miniature planetary system. After completing its historic encounter, Voyager continued toward Saturn. For centuries, Saturn's rings had fascinated observers looking through telescopes on Earth. From a distance they appeared smooth and continuous. Up close, Voyager revealed something astonishing. The rings were actually made of countless individual particles ranging in size from tiny grains of ice to massive chunks of frozen rock. Gravitational interactions created waves, gaps, and delicate patterns that constantly shifted over time. The spacecraft also photographed Saturn's diverse family of moons. Several displayed fractured surfaces and mysterious landscapes unlike anything previously observed. These early discoveries encouraged scientists to rethink how icy moons evolved deep within the outer solar system. By the early 1980s, Voyager 1 had successfully completed the mission it had been built to perform. Most spacecraft would have ended their story there. Voyager's greatest journey, however, was only beginning. Leaving Saturn behind, it accelerated toward the edge of the Sun's influence. Ahead lay a region no spacecraft had ever entered. For decades, Voyager continued traveling through the outer reaches of the solar system. There were no dramatic planetary flybys waiting ahead. No spectacular photographs. Only darkness stretching across billions of kilometers. Its mission quietly shifted from planetary exploration to something even more ambitious, becoming humanity's first explorer of interstellar space. As the years passed, engineers watched the spacecraft slowly approach an invisible frontier called the heliopause. This boundary is not a physical wall. Instead, it marks the place where the solar wind, the continuous stream of charged particles flowing outward from the Sun, finally loses its battle against the thin gas filling interstellar space. Crossing that boundary would mean leaving the protective bubble surrounding our solar system. In 2012, that historic moment finally arrived. Voyager's instruments detected a dramatic decrease in particles originating from the Sun. At the same time, cosmic rays arriving from distant regions of the Milky Way increased sharply. The spacecraft had crossed into interstellar space. Without fanfare. Without witnesses. Without slowing down. For the first time in history, a machine built by humanity had entered the vast region between the stars. And what Voyager discovered there surprised scientists. Interstellar space was not completely empty. Instead, it contained an incredibly thin mixture of gas, plasma, magnetic fields, and energetic particles. Even in the enormous darkness separating stars, invisible structures stretched across unimaginable distances. The silence of deep space was not truly silent. It carried subtle waves and disturbances produced by powerful events occurring light years away. Voyager had become humanity's first direct observer of this mysterious environment. Every signal it transmitted expanded our understanding of the galaxy beyond the solar system. Its greatest discoveries were no longer coming from planets. They were coming from the seemingly empty space between them. Today, Voyager 1 continues a journey unlike any other spacecraft in human history. More than 24 billion kilometers from Earth, it travels through the interstellar medium, a region once thought to be almost completely empty. Yet every signal returned by the spacecraft has revealed a different reality. The darkness between the stars is filled with extremely thin clouds of ionized gas, invisible magnetic fields, and high-energy particles racing across the galaxy. To the human eye, this region would appear completely black. But to Voyager's instruments, it is alive with subtle activity. Scientists have detected faint plasma waves traveling through interstellar space. These waves are often generated by distant stellar explosions, powerful shock fronts, and enormous disturbances that move across the galaxy for years before eventually reaching Voyager's location. Each detection tells astronomers something new about the environment beyond our solar system. It is no longer viewed as an empty void. Instead, it is a dynamic region where gravity, magnetic fields, and energetic particles interact across distances that are almost impossible to imagine. Every transmission from Voyager helps researchers understand how stars influence the space between them and how our own Sun interacts with the wider Milky Way. Yet gathering this information has become increasingly difficult. Voyager 1 is powered by a radioisotope thermoelectric generator that converts heat from slowly decaying plutonium into electricity. Every year that power supply becomes weaker. To keep the spacecraft operating, NASA engineers have gradually switched off non-essential systems, carefully deciding which scientific instruments should remain active and which must be sacrificed to preserve the mission. Each shutdown extends Voyager's life a little longer. It is a remarkable example of engineering ingenuity. The spacecraft was originally expected to operate for only a few years. Instead, it has continued sending valuable scientific data for decades beyond its planned mission. Communicating with Voyager has also become one of the greatest technical challenges in space exploration. Its radio signal travels at the speed of light, yet because of the enormous distance, a single transmission takes well over 20 hours to reach Earth. A command sent back requires another journey of similar length. Simple conversations are impossible. Every instruction must be planned days in advance, carefully tested, and transmitted with extraordinary precision. There are no second chances. If something unexpected happens, engineers must patiently wait nearly 2 days before learning whether the spacecraft responded successfully. Despite these challenges, Voyager continues to answer. Each faint signal received by NASA's Deep Space Network is a reminder that humanity's most distant explorer is still alive. Attached to the side of the spacecraft is something even more extraordinary than its scientific instruments. The Voyager Golden Record. This gold-plated copper disc contains greetings spoken in dozens of languages, music from many cultures, natural sounds from Earth, photographs of humanity and our planet, and simple scientific information describing where the spacecraft came from. It was never intended as a realistic attempt to contact extraterrestrial civilizations. Instead, it serves as a time capsule. A message explaining who we were at the moment humanity first reached beyond the boundaries of its home. Long after Voyager's electronics finally fall silent, the spacecraft itself will continue traveling around the center of the Milky Way. For tens of thousands of years, it will drift silently through interstellar space. It may pass near distant stars. It may never encounter another world. Or perhaps, millions of years from now, another civilization could one day discover this tiny machine and recognize it as evidence that intelligent life once existed around an ordinary yellow star. Whether that ever happens is impossible to know. But the idea itself reflects one of humanity's greatest strengths: curiosity. Voyager 1 was built to answer scientific questions. Instead, it inspired entirely new ones. What lies beyond the edge of our solar system? How does interstellar space shape the evolution of galaxies? How many other planetary systems send wandering objects into the darkness between the stars? Future missions will continue searching for those answers. More powerful telescopes, advanced robotic probes, and perhaps one day interstellar spacecraft will explore regions that Voyager can never reach. Yet every future mission will follow the path opened by this remarkable explorer. Nearly 50 years after launch, Voyager 1 remains one of humanity's greatest achievements. Not because it traveled the fastest. Not because it carried the most advanced technology. But because it proved that determination, careful engineering, and scientific curiosity can carry a small spacecraft farther than anyone once believed possible. Its mission is no longer simply about exploring space. It is about representing humanity itself. A tiny messenger crossing the immense darkness between the stars, carrying the story of a civilization that refused to stop asking questions.